If you log into almost any digital course today, you will find a standardized, rigid architecture. The majority of learning management systems rely on a linear checklist of discrete, sequential events. This structure is the result of functional fixedness in instructional design. We have been trained to view assessments strictly as terminal evaluations, tools used to judge past learning, rather than tools used to actively generate it. The workflow is highly predictable. A student reads the content, participates in a designated activity, and then stops to take a final exam. These are called blocked assessments. They treat testing as a separate, fragmented episode, isolated from the context of the course, actively breaking the learner's state of cognitive flow. Course designers often place rigorous formative and summative checkpoints throughout this assembly line. Yet, this architecture consistently yields low engagement and poor long-term retention. To solve this, instructional designers have to transition away from linear models and build integrated, holistic feedback architectures. If the assessment is relegated to a disconnected endpoint, the learner loses the momentum required to retain complex information. The assessment itself must become the continuous, invisible engine that drives the learning experience forward. In an integrated framework, assessments pull the learner in and out of deep engagement, actively inducing a state of flow. This framework reconfigures the spatial relationship between the learner, the course content, and the assessment mechanisms. We will build this environment layer by layer. We begin at the very center, the learner's internal state, and work our way outward to the course interface. By visualizing course design as a series of integrated rings instead of a straight line, we can engineer an environment designed to dynamically sustain human attention. Conventional course design targets exactly one area of human capacity, the cognitive dimension. It relies on factual recall, text comprehension, and rote memorization. The first layer of our model engages 4 distinct dimensions of the learner's internal state. The emotional dimension builds confidence. The behavioral dimension encourages new strategies. And the social dimension focuses on open communication and active collaboration with peers. In practice, this means restructuring your metrics. When designing a rubric for an asynchronous group discussion, you assess for group cohesion and emotional expression, rather than just tracking the word count. If an assessment only measures cognitive output while ignoring emotional frustration or social isolation, it fails to capture the reality of the learning experience. But relying purely on the learner's internal state introduces a psychological hazard known as the illusion of competence. This graph illustrates the problem. Learners with high expectations often severely miscalibrate their metacognitive abilities, overestimating their performance. Without intervention, they maintain this optimistic illusion. We use correction points, feedback mechanisms, to snap that confidence line back down to reality. The first tool to correct this is iterative self-assessment. Deployed immediately after a task, it forces the student to evaluate their errors and build metacognitive awareness. But the student also needs external calibration. Leveraging instructor feedback forces the learner to confront the reality of their performance, shifting them away from a fixed mindset and toward a growth mindset. Integrated assessments do not just assign grades, they are active psychological calibration mechanisms required to align a learner's perceived competence with their actual demonstrated skill. To deploy these correction points without interrupting cognitive flow, we use stealth assessments. These are invisible, formative checks embedded directly into the environment. Looking at the next structural layer of our diagram, we see exactly where these stealth assessments live. We use a mechanical design strategy called spacing and interleaving. Instead of block testing at the end, assessments alternate continuously between content presentations. Interleaving feels significantly more difficult for the learner initially, but because it forces them to circle back to previously exposed content, it drastically pays off in long-term retention. Concept mapping is an effective stealth assessment. Building a concept map forces a learner to externalize their structural schemas. By mapping out the relationships between ideas, they permanently reorganize their own cognitive structure. Another powerful tool is the scenario-based activity. Interactive scenarios embed critical decision points and consequential feedback directly into a narrative. Because the challenges are contextualized, they engage deeper emotional and cognitive levels than any traditional quiz format. By interleaving stealth assessments into social and content interactions, The system is testing the learner continuously without ever breaking the narrative flow of the course. Course designers maintain flow by treating feedback as an ongoing dialogue between the learner and the system. The modality of that dialogue matters immensely. Standard text commentary functions differently than rich media. When instructors utilize voice and screencasting feedback, students retain content better. They hear the nuance, the empathy, and the specific intent behind an instructor's voice. Adjusting the timing of this feedback alters its effect. Prompt feedback solidifies immediate concepts, while delaying feedback on complex tasks forces deeper, metacognitive reflection. We can also introduce learner agency through tools like learning contracts, where students actually participate in designing the assessment rubrics. This shifts them from passive subjects to active architects of their own learning. When delivered with empathy and agency, feedback is the primary mechanism for sustaining motivation. It transforms an assessment from a final judgment into a collaborative coaching session. This brings us to the final, complete architecture. The outer course structure acts as the container. It organizes the learner dimensions, the interactions, and the stealth assessments into a single, holistic environment. By building outward, starting from the learner's internal state, and layering interleaved modalities, designers successfully eliminate the fragmented checklist approach. Online learning success is measured by more than a score at the end of a module. High-impact learning occurs when the assessment is engineered to be the learning material itself.